Simplifying radicals with variables. You simplify radicals with variables in the same fashion that we simplify numbers. So let's look at a number. The square root of 9 is equal to the square root of 3 times 3. There's one pair of 3 as factors underneath the radicand, so the square root of 9 is 3. The square root of x squared is equal to the square root of x times x. There's one pair of x's under the radicand, so the square root of x squared is equal to x. The square root of x to the fourth is equal to the square root of x times x times x times x. There are two pairs of x's under the radicand, so the square root of x to the fourth is x squared. The square root of x to the sixth is equal to the square root of x times x times x times x times x times x. There are three pairs of x's under the radicand, so the square root of x to the sixth is x to the third. So when taking the square root of a variable, you look at the exponent and divide it by 2. X squared, 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 100 divided by 2 is 50. The square root of x to 100 is x to the 50. So here we've looked at variables with even exponents. Let's look at variables with odd exponents because they don't divide evenly by 2. So let's look at the square root of 27 to start with. The square root of 27 can be written as the square root of 3 times the square root of 3 times the square root of 3. There's one pair of 3's underneath the radicand that can be taken out from under. So instead of writing the square root of 3 times 3 times 3, the simplified form is 3 square roots of 3. So we've taken one pair out and left the remainder underneath. And we're going to do the same thing with the variable. So here we have the square root of x to the 3, which when it's expanded is x times x times x. So we have one pair outside and we leave one inside. So the square root of x to the 3 is x times the square root of x. The square root of x to the 5th. We have one pair, two pair, and one left over. 5 divided by 2 is 2 with 1 left over. The square root of x to the 7th. 7 divided by 2 is 3 with 1 left over. The square root of x to the 9th. 9 divided by 2 is 4 with 1 left over. So that's how we simplify radicals with variables. We're going to talk about the product property of radicals. The square root of AB is equal to the square root of A times the square root of B. An example of this is the square root of 125 can be written as the square root of 25 times the square root of 5. And we know that can be simplified to 5 square roots of 5. So let's practice a few of these. The square root of 12 can be written as the square root of 4 times the square root of 3, which is 2 square roots of 3. The square root of 90 can be written as the square root of 9 times the square root of 10, which is 3 square roots of 10. The square root of 90 x squared y. We need to simplify this. First, we're going to simplify the number 90, then the x, and then the y. So the square root of 90 can be written, as we just saw, as 3 square roots of 10. We're looking at the x now. It's an x squared. The square root of x squared is x. The square root of y is the square root of y. So 3x times the square root of 10y is the simplified version. Number 4. The square root of 50, a to the 4, b to the 3. The square root of 50 is the square root of 25 times 2, or 5 square roots of 2. A to the 4th, 4 divided by 2 with none left over. B to the 3rd is 1 with 1 left over. Square root of 72, m to the 5, n to the 3. The factors of 72, 2 and 36. So 6 square roots of 2. M. 5 divided by 2 with 1 left over. N to the 3rd, 3 divided by 2 is 1 with 1 left over. Number 6, the square root of 48, x to the 3rd, y squared. So 16 and 3 are factors of 48. So the square root of 48 is 4 square roots of 3. X to the 3rd, 3 divided by 2 is 1 with 1 left over. Y squared, 2 divided by 2 is 1. The quotient property of radicals. The square root of a over b is equal to the square root of a divided by the square root of b. Here's an example. The square root of 25/4 can be rewritten as the square root of 25 over the square root of 4. Now we're able to simplify that number. The square root of 25 is 5. The square root of 4 is 2. Square root of 59 is equals to the square root of 50 over the square root of 9. To simplify, the square root of 50 is 5 square roots of 2. Square root of 9 is 3. And the square root of 80 over 25. Well, the square root of 80 over the square root of 25. Factors of 80 include 5 and 16. So the square root of 80 can be simplified as 4 square roots of 5. And the square root of 25 is 5. So when working with radical expressions are in simplest form if no radicands have perfect squares factors other than 1. No radicands contain fractions, and no radicals appear in the denominator of a fraction.